Hello, welcome back to Learn Economia. Having discussed a lot about autocorrelation, here we are going to look into another important problem with respect to Euler's regression, which is heteroscedasticity. So, what is heteroscedasticity? So, this is actually something which is considered as unequal scatter of residuals or error terms. It actually refers to the case where there is a systematic change in the spread of the residuals over a range of measured values. Here it means that when you run for Euler's regression, you will be having a non-constant variance. If you have a constant variance, that means that you have homoscedasticity. Heteroscedasticity is a problem because Euler's regression assumes that the residuals come from a population that has homoscedasticity, which means that a constant variance. Okay, so when heteroscedasticity is present in your regression analysis, you will be having a lot of issues. You will be facing a lot of issues. We will be dealing with all these things in this video. We will be looking into the way in which heteroscedasticity becomes a part of your regression when you are going for time series data, when you are going for cross-section data. Then I will let you understand more about heteroscedasticity by looking into certain examples, and also we will be looking into the causes, consequences, etc. of heteroscedasticity, and the test for heteroscedasticity will be looked into in this video, and finally we will be looking into the solutions for heteroscedasticity. So this is all about heteroscedasticity. With respect to cross-section studies, I hope you know the difference between time series data and cross-section data. The time series data is a data, it's a data set we collect by looking into the looking into a particular aspect over a period of time. Now, with respect to cross-section data, we are looking into an aspect at a point of time. So that's all about cross-section data and time series data. So with respect to cross-section studies, which has got or which have got very large or very small values, uh, in this case you'll be having a problem of heteroscedasticity. If you take the case of an example, a cross-section study which involves United States can have low values as well as for large values. For example, if you take the case of income or something, you will be having people income at a particular year, or income in a particular year in a particular country. You will be having, if you are looking into the case of annual income, okay, so that means that you will be having people with high income as well as people having large income, high income or people having low income, right? So these two are the two extreme cases, and if one of the values is more, if people with large income or high income is more, or people with low income is more, then that means that this would have a issue with respect to range, which will lead to what is known as heteroscedasticity in your regression analysis. With respect to time series data, here too you have heteroscedasticity. The dependent variable changes significantly from the beginning to the end of the series. If you take the case of an example, just think about a model. If you're going for the model of the sales of DVD players from the first sales in 2000 to the present, then the number of units sold will be vastly different, right? Or if you are modeling time series data and measurement error changes over time, you have a problem of heteroscedasticity in your model. For example, if the measurement error decreases over a period of time, then you can expect the error variance to diminish over a period of time. So that's all about heteroscedasticity in time series data and heteroscedasticity in cross-section data. Just look into an example so that you will be able to understand the concept very clearly. Okay. So just think about household consumption model. We know that consumption is something which is dependent upon income. So when I say household consumption, it is something which depends upon the household income. Here you will be able to find that the variability in consumption increases as the income increases. Just think about the case of lower income household and higher income household. Okay, how their pattern of consumption changes with their changes in income. Lower income household, they are less variable in absolute terms because they need to focus on necessities, and there is less room for different spending habits, right? because these people, whatever income they get, they spend it on their necessities. But on the other hand, with respect to the high income households, these people are able to purchase a wide variety of items, which would include luxury items, necessities, comfort, etc., whatever, right? So this is something which would lead to a broader spread of the spending habits. Next, we are going to see the difference between pure heteroscedasticity and impure heteroscedasticity. Okay, in the case of pure heteroscedasticity, you will be having cases where you specify the correct model and you observe the non-constant variance in the residual plots. Whereas in the case of impure heteroscedasticity, you will be having cases where you incorrectly specify the model and you will be having non-constant variance. Now, when you observe heteroscedasticity by looking into your residual plots, it's very important to understand whether you have a pure or impure heteroscedasticity, because you'll be getting different solutions here. Having discussed a lot about the meaning of heteroscedasticity, examples of heteroscedasticity, types of heteroscedasticity, etc., we are going to see the causes of heteroscedasticity. What will be the causes of heteroscedasticity? What will be the causes of non-constant variance? If you have incorrectly assuming linear relationship in your models, then you are more likely to face heteroscedasticity. And also, if the distributional assumptions are incorrect, you will be facing heteroscedasticity. If your models which perform better for some subgroups rather than others, you will have heteroscedasticity. So this is where the difference between high income groups and low income groups comes. Okay. Now, the existence of autocorrelation means that the standard computational standard errors are constantly p-values are misleading. We have done a lot of videos on autocorrelation. You can go through the same. Heteroscedasticity, so this can occur in a range of values, especially when you have a larger value and a smaller value. In some cases, the variance increases proportionally with this factor, but remains constant as a percentage. Because there is large ranges, or because there are large ranges associated with the problem of heteroscedasticity, some types of models are more prone to heteroscedasticity. So this is something which is very much important to understand. Now, having discussed the causes of heteroscedasticity, let's understand the ways which could be used to dictate the problem of heteroscedasticity. As I have already mentioned, if you go for residual plotting, this is considered to be one of the easiest method. As in the case of autocorrelation, this is one of the easiest method to dictate the problem of heteroscedasticity. Once you fit for a regression line, then you can create a scattered plot, which will be helping to understand whether you have a heteroscedasticity or not. So here, actually, what you are seeing is a scattered plot, and here the residuals become much more spread out as the fitted values get larger. The cone shape is a sign of heteroscedasticity. The most widely used test for heteroscedasticity is then Bridges-Pagan test. So this is used with respect to multiple linear regression, where you will be having the outcome variable in square residuals. The predictors are same predictor variable used in the original model. Having discussed the causes of heteroscedasticity, let's understand the consequences of the same. What will be happening if your model faces a problem of heteroscedasticity? If there is heteroscedasticity, then it will lead to wrong coefficient estimate. That means that it does not cause bias in the coefficient estimate, and actually it causes bias in the coefficient estimate, and lower precision would be there, which would lead to problems in your estimation. Then you will be facing p-values that are smaller than the actual ones. I mean, the p-values are smaller than they should be. This effect occurs because heteroscedasticity increases the variance coefficient estimates, but Euler's procedure does not or it could not cover, or it could not dictate this increase. As a result, Euler's would be giving you some t values or f values using the underestimated variance, which will lead you to conclude that the model term is statistically significant when it is actually not significant. Having this understood the consequence of heteroscedasticity, heteroscedasticity, let's understand the ways which could be used to do away with the problem of heteroscedasticity. Here, either you can go for transformation of the dependent variable. That is one of the important and effective way to do away with the problem of heteroscedasticity. That is, either you can go for some taking the log of the dependent variable, or you can go for some other ways. If you're going for the log, for example, if you have some population size is your independent variable, and your number of flower shops in the city as the dependent variable, then you can go for the population size to predict the log of the number of flower shops in your city. Using log of the dependent variable rather than the original dependent variable will be able to handle the problem of heteroscedasticity with much ease. Or else you can go for a redefinition of the dependent variable. That means that by just looking at an example, you can see that instead of using the population size to predict the number of flower shops in the city, you can use population size to predict the number of flower shops per capita. Okay, so here this will be able to reduce the problem of heteroscedasticity. That is considered to be this too is considered to be a very effective step. Or else you can go for weight regression method. This type of regression assigns a weight to each data point based on the variance of its fitted value. You can see that this gives small weights to data points that have higher variances, and also this will help to shrink their square residuals. And when proper weights are used in the models, this will be able to eliminate the problem of heteroscedasticity. Okay, so by just looking into the summary of the ways which you could use to deal with the problem heteroscedasticity, either you can transform the variables, or you can transform the numerical predictive variables, or you can build some separate model for subgroups, or you can use models that explicitly model the difference in the variance, or you can go for weight regression, etc. Or else you can go for some other methods as well. I'm not looking into that here. And then that's all about heteroscedasticity. I hope you could get some idea with respect to this particular method, not problem in the Euler's regression model. So it is when you face a problem heteroscedasticity in your model, just think that this is a fairly common problem, and you can have many steps, many methods to dictate the problem of heteroscedasticity, and also there have been many solutions to the problem of heteroscedasticity. You can use any of these. You can use any of the method to test for heteroscedasticity, and also you can, if you once you dictate the problem, once you understand the cause of heteroscedasticity, just treat the cause, so that treatment of the cause will be able to help you to get out of the problem of heteroscedasticity. So by using that, you can get out of the problem of heteroscedasticity. By that, we end today's video. Please like, share and subscribe to this channel for more videos, and be a part of my Telegram group and Telegram channel to discuss your doubts. And also, if you want me to do any of the videos with respect to any of the topics which you want me to cover, please comment that in the comment box. Please do that. I'll be providing the links of both my Telegram group and Telegram channel also in the description box. You can use the same as well. So with that, we end. Thank you.